There, thank you for clicking on this. This video is intended to be an embedded video in a larger lesson on equivalent forms of quadratics. If you clicked onto this video just out of the blue to review some completing the square, if you want to, please go check out the larger lesson that will put these problems into some context so you can see what we're actually doing with them. Now, what we're going to do here is take the polynomials from the lesson and we're going to go through completing the square in this visual way using the tiles. I have here x squared plus 4x minus 1. That's the first of the examples. And literally, we are going to rearrange these tiles to make the largest square possible. We'll start with the blue square. So this is a square. It has a width of x and a height of x and an area of x squared. And I'm going to start there and build onto that. So if I take this rectangle is x by 1. So it's got a height of x and a width of 1. So the area is 1 times x, or x. I have now made the width of my shape here bigger than the height. So I have x plus 1, but on my height, it's just an x. So I'm going to have to take another one of these rectangles and put it on the bottom. And what that does is it preserves the squareness of it. So we have x plus 1 and then another x plus 1. Now I've got two more rectangles here, so I'm going to repeat that process. And we end up with this square shape that is x plus 2 going across and x plus 2 going down. Now, we do have this vacant spot here, and this is where we get to the idea of, well, we have to complete the square. So keep in mind what these numbers are. This is a positive 1 and a positive 1, positive 1, positive 1. So this is a 2 by 2 square. So what we're missing there is 4. I'm going to pull in 4 ones. Now, if I do that, I have now totally changed the number of tiles that I have. So this is no longer x squared plus 4x minus 1. This is x squared plus 4x minus 1 plus 4. To balance that out, I also need to bring in 4 negative ones. And these are what are called zero pairs because 1 plus negative 1 is 0. So if I bring in the positive ones, I've got to bring in the negative ones to go with it. Now I can use the positive ones to complete the square. And my negative ones that I imported are going to come over here. And now I have completed the square. So what I have here is x plus 2 times x plus 2. That gives me that area right there, or x plus 2 all squared minus 5. So when you go back over to the video, okay, we're going to do this out algebraically, and you'll see the x plus 2 all squared minus 5. The second problem from the video is x squared minus 2x plus 5. Now, this one is going to do something a little bit different. I'm going to kind of take you through a process. You're like, why is she doing that? Like, she doesn't really need to do that, but it'll make sense when we go back to the video. So same deal. I'm going to arrange these tiles so that I have the biggest square possible. And I start with my blue square because I know that's a square. And I'm going to build off that, but I have to build off it in this predictable way where I split my x's in half and then add the same number to each side. And you really want to notice that with the pattern here. You've got to take however many x's you've got to split them in half, divide them in half, divide them by 2, and then that's how many are going to go on each side. And then you're going to have this piece here. Now you might be saying, okay, this is -1 times -1 because the area here is negative x, so it's x times -1. Now you might say, well, the fastest way to do that is to pull that in because -1 times -1 is +1, and then I'm left with +4. Okay, and that technically does work as far as your tiles are concerned. So this would be x minus 1 times x minus 1 plus 4, or x minus 1 all squared plus 4. However, algebraically, that's not what we're going to do, although you could probably figure out a way to do that. typically algebraically, so we can make this into an algorithm, is we're going to leave that batch alone, and instead of pulling the one from there, we're going to pull the one from here and then bring in the -1 with it. So we have that 0 pair again, 1 plus -1. And then when we go to move that -1 over to our pile, oh, we realize we have a 0 pair there, and then we pull that out. And you notice that we land in the same place, x minus 1 all squared plus 4. And the reason we kind of go through that is because you'll notice in this problem, yeah, we could just yank that one out of the pile that we had over there on the side there and complete the square with that, but we couldn't do that in the previous problem. So are you welcome to do this if you can make sure you understand how that works? Absolutely. But for the purposes of kind of coming up with a procedure or a set of steps that we know is going to work all the time, like so in the previous example too, we just try to keep that consistent. We bring in that 0 pair. All right, so I hope that helped. Go ahead, click back to the lesson video, and we'll proceed with the algebraic process.